Hi class, this is the assignment for special right triangles. This is day 1. And today we just looked at 45, 45, 90-degree triangles. They're right triangles and they have special qualities. And before we start, let's review the two formulas. If you are given the leg, then the hypotenuse is going to equal the leg times the square root of 2. And if you want to find the leg, because you're given the hypotenuse, then the leg equals the hypotenuse divided by the square root of 2. So these are the two ideas that we're going to be using to solve for the missing sides in these 45, 45, 90-degree triangles. Okay, so let's look at number 1. In number 1 we have a 90-degree triangle. These are congruent to each other, so this is a 45, 45, 90. These angles are equal and they have to be 45. We're given the leg. We want to find the hypotenuse, which is x. So we want to find the hypotenuse. So you take the leg and multiply it times the square root of 2. So if I want to find the hypotenuse, x, that's going to equal the leg times the square root of 2. Hypotenuse, x, is going to equal the leg times square root of 2. And we're done. Here we're looking for the hypotenuse again. So the hypotenuse, y, is going to equal the leg times the square root of 2. And we're done. Number 3. We're given the legs, both legs this time. But we're just going to use one of them. Oh, we were given both here too. Actually, we were given all the legs already, which shows us that this is a 45, 45, 90. Okay, so 3 square roots of 2, z is going to equal, our hypotenuse is going to equal 3 rad 2 times rad 2. Okay. Hypotenuse is going to equal, so z is going to equal the leg times square root of 2. This equals 3 times, this equals rad 4, which is 2, and we get 6. Okay, so all 3 of these examples, we took the leg and multiplied it by rad 2. Leg times rad 2. Leg times rad 2. Now here we're given the hypotenuse and we're trying to find the leg, so we're going to use the formula L equals h over square root of 2. But this time we're going to divide. So we're going to take the hypotenuse, so our leg, x, is going to equal our hypotenuse divided by square root of 2. Instead of taking the leg and multiplying it by square root of 2 to find the hypotenuse, we are going to be using the hypotenuse and dividing by the square root of 2 to find the leg. Well, we can't leave it like this. We have to rationalize it, so we multiply top and bottom by square root of 2. Well, square root of 2 times square root of 2 is just 2. And on the top we have 4 on the outside, rad 2 on the inside. When we simplify this, we can only simplify the numbers that are outside the radical. We have 4 divided by 2, so that's 2 rad 2. 4 divided by 2 is 2, and we're left with the rad 2. Number 5. We're given the hypotenuse, so we're trying to find the leg. Remember, the leg is going to be equal to the hypotenuse divided by square root of 2. The leg equals the hypotenuse divided by square root of 2. Hypotenuse is 10 divided by square root of 2. Let's rationalize that. And on the top we get 10 rad 2, and on the bottom we get rad 2 times rad 2, which is just 2. Remember, that's rad 2 times rad 2 is rad 4, and the square root of 4 is 2. When we multiply it by itself, it gets rid of the radical. Now, we can simplify this some more, because we have a 10 and a 2 here outside the radical, so that's 5 rad 2. Number 6, we're given the hypotenuse, so to find the leg, we need to take the hypotenuse and divide by square root of 2. Those cancel, and we get c equals 3. Here's our right triangle. It's half of the square. The hypotenuse is 5, so if we want to find the leg, d, we need to take the hypotenuse and divide by the square root of 2. Remember, the leg is equal to the hypotenuse divided by the square root of 2. That's the formula I'm using here. I'm putting in the hypotenuse and dividing. Okay, we can't leave it like this. We need to multiply by the square root of 2. So this becomes 2 on the bottom, and on the top we get 5 rad 2. And number 8. We're given here's a 45, 45, 90. These are congruent, so these are 45, and these are 45. So I want to solve for the leg, so we need to use the formula here. Leg equals hypotenuse divided by square root of 2. So take the hypotenuse, 7 rad 6, and divide by the square root of 2. I'm taking the hypotenuse and dividing by square root of 2. We need to rationalize this. And we get 7 square root of 12, right? Outside times the 1 is 7. Inside times the 2, 6, divided by 2. We're almost done. We need to simplify this radical, and the square root of 12 can be written as, let's rewrite this whole thing, 7 times square root of 4 times square root of 3, all over 2. There's a perfect square factor of 4 in there. We need to take that out. So now we have 7 times square root of 4 is 2, and rad 3, and divide by 2. So we get 14. 7 times 2 is 14. Divided by 2, that's 7. This is going to be 7. So the answer is 7 rad 3. Watch that again if you need to. Okay. We ended up with 7 rad 12. I separated the 12 into two factors, 4 and 6. We took the square root of the 4 here. So we have 7 on the outside times 2 on the outside now, rad 3. And then we get 14 over 2 outside here, which is 7. So we get 7 rad 3. Number 9, we're given the leg. Remember, the hypotenuse equals the leg times square root of 2. So when you're given the leg, you multiply by square root of 2 to find the hypotenuse. So F is going to equal 7 rad 6 times rad 2. Okay, that's going to be 7 radical 12. And this can be simplified a little bit more. Remember, this is 7 times, let's see, rad 4 times rad 3. I can rewrite this. I can take the square root of 4, so we get 7 times 2. This becomes a 2, rad 3. So our answer is 14 rad 3. Number 10, there's a square. That gives us a lot of information right there. That means all the sides are congruent. Right? And this is a 90-degree angle. There are a number of ways to solve this. I'm going to look at it as the big triangle. So I'm going to find missing diagonal. Get my highlighter here. So I'm going to use this triangle right here. So that means I have a leg of 1, and here's my hypotenuse. Now, why am I trying to find this hypotenuse? Because this diagonal is going to be congruent to this diagonal. Remember, the diagonals in squares are congruent. Oh, excuse me. Okay, so as I was explaining is that this diagonal right here is going to be congruent to this diagonal. So if I want to find this diagonal, which is also the hypotenuse of this triangle, if I find this diagonal, then I'll know what this whole diagonal is. And V is going to be half of it. Alright, so I'm going to find this diagonal. Now, we have the leg, so remember the hypotenuse, this is the hypotenuse here, is equal to the leg times square root of 2. So the hypotenuse here is equal to 1 square roots of 2. Well, I don't need to write it like that. I can just take away the 1, and it's just square root of 2. So this whole diagonal is square root of 2. But so is this one. And not only that, I want to take it in half because V is just half of it. So I'm just going to take the square root of 2 and divide by 2. And that will give me this piece. Now I'm going to show you another way to do it. The other thing that we can remember about diagonals of a square is that they meet at a 90-degree angle. So these are all 90-degree angles in here. So I could look at this little triangle or this little triangle right here. See, I could look at this triangle right here. This is a right triangle, and I was given the hypotenuse. So to find the leg, this is 45, this is 40, this is a 45, 45, 90 as well. So I can just take the leg, the hypotenuse. So find the leg, I take the hypotenuse and divide by the square root of 2. So I would take 1 and divide by the square root of 2. And then I would have to rationalize that. And I would get square root of 2 over 2. I get the same answer. So I could have used this small 45, 45, 90 right here, using the given hypotenuse. Or I use the big 45, 45, 90 triangle, and I use the leg and multiply it by the square root of 2 to find this whole diagonal. Then I divide it in half. Number 11. Well, this is a square, so that means the diagonal is going to bisect the angle, so x equals 45 degrees. So we have these 45, 45, 90-degree triangles. Now if I want to find y, I can look at this triangle right here. The leg is 12. Remember, the hypotenuse equals the leg times square root of 2. So I just take the leg and I multiply it times the square root of 2. So the hypotenuse is just y. So y equals 12 square roots of 2. Take the leg, multiply it by square root of 2 to find the hypotenuse. If you have the hypotenuse, you take the hypotenuse and divide it by square root of 2 to find the leg. Find the length of the leg of a 45, 45, 90 triangle with a hypotenuse that is 25 inches. I like to draw pictures of this. Here's our 45, 45. And we're told that the hypotenuse is 25. Well, to find the leg, you have to take the hypotenuse and divide it by the square root of 2. So if I want to find the leg, I take 25 and divide it by the square root of 2. Rationalize that. And we get 25 rad 2 over 2. Here's a perimeter of a rectangle. Notice this is quadrilateral. It has all 4 right angles. If 3 of them are 90, then of course the 4th one is also. So this is a rectangle. This side is 5. This side is 5. Opposite sides are congruent. It's also a parallelogram, so opposite sides are congruent. If we add these all up, we'll have the perimeter, right? 5 plus x plus 5 plus x. So 5 plus x plus 5 plus x equals 34. Well, that's 10. The 5 and the 5 make 10. And the x and the x make 2x. So 2x plus 10 equals 34. Subtract 10, and we get 2x equals 24. Oops, sorry. Divide by 2, and we get x equals 12. 12 plus 12 is 24, plus 10 is 34. Number 14, we have here an equilateral triangle, and we know that because all the sides are 10. And when you drop down the altitude from the vertex to the opposite side, it cuts this equilateral triangle in half. This angle and this angle are congruent. They share this side. So that means that if this triangle, this big triangle is cut in half, then this side here is cut in half. 5 and 5. I'm going to solve for the height of this triangle using the Pythagorean theorem. So h squared plus 5 squared equals 10 squared. H squared plus 25 equals 100. Subtract 25. H squared equals 75. Take the square root of both sides, and we get h equals the square root of 75. It's got a perfect square factor in there. I know that 75 is equal to 25 times 3. I just split it up like that. Square root of 25 times the square root of 3. and the square root of 25 is 5. So we get 5. That goes away. Add 3. And so our height in this equilateral triangle, when the sides are 10, is 5 rad 3. 15. I see a right triangle here and a right triangle here. Now these are not 45, 45, 90 because this side and this leg are not congruent. Remember, in a 45, 45, 90, the legs are congruent. So we're going to use Pythagorean theorem. I'm going to find the length of this piece right here in this triangle, and then I'm going to find the length of this piece right here, and then I'm going to add them together, and that will give us the whole x. So to find this piece right here, we do 1 squared plus 2 squared. That equals 1 plus 4. That equals 5. And that's going to equal this piece right here. Let's call it c. So c equals the square root of 5. Right? 1 squared plus 2 squared equals c squared. So 1 plus 4 is 5. There we go. This is square root of 5. Now I'm going to do this triangle. 2 squared, let's call this d. 2 squared plus 3 squared equals d squared. 4 plus 9 equals d squared. 13 equals d squared. Take the square root of both sides. And we get d equals the square root of 13. So if I want to know what this whole x is, I'm going to take square root of 5 and add it to square root of 13. So my x is equal to square root of 5 plus square root of 13. Now, why don't I add these together? Because the radicands are not the same. So we'll just leave it just like that. Number 16, Pythagorean theorem. 5 squared plus x squared equals 10 squared. 25 plus x squared equals 100. X squared equals 75. Take the square root. Oops. X equals square root of 75. And I can split that into a pair of factors that has a perfect square in it. So this is 25 times 3, which is the same as square root of 25 times the square root of 3, which is equal to 5. Add 3. I can take the square root of this. I'm going to leave this in the radical sign. 17, we're going to use Pythagorean theorem. 2 rad 3 squared plus 2 squared equals x squared. So leg squared plus leg squared equals x squared. We have to be very careful when we square this. The long way would be to say this is 2 rad 3 times 2 rad 3, right? You take everything that's inside of here and multiply it by itself. Plus 2 times 2 is 4 equals x squared. So if I'm going to multiply this together, the outside gets multiplied, that's 4. And rad 3 times rad 3 is rad 9, or 3. So we get 4 times 3 plus 4 equals x squared. That's 12 plus 4 is 16. Right, that's 12 plus 4. Oops. 12 and 4. So 12 plus 4 is 16. That equals x squared. If you take the square root of both sides, guess what? You get x equals 4. It's a perfect square. Okay, that's the front side. Pause it, have it go slow, help yourself with that. 4, 5, and 6, do these sides make a triangle? And if they do, is it going to be an acute, a right, or an obtuse? This is the converse of the Pythagorean theorem. Okay, I got interrupted, but here we go. Here are the 3 sides. We're going to check to see if they make a triangle. Remember, to see if they can make a triangle, you add the 2 smaller ones. So 4 plus 5. Is that greater than 6? 9 is greater than 6. So yes, these can make a triangle. Now to find out if it's acute, right, or obtuse, we need to use the converse of the Pythagorean theorem. So we're going to take the long side, which is 6, put that on the left. 6 squared. Is that going to be less than, equal to, or greater than? Now we take the 2 shorter sides. 4 squared plus 5 squared. Is it going to be less than, equal to or greater than the sum of the two legs, well, the two smaller sides squared and added together. Okay, let's see. This is 36. This is 16 plus 25. So this is 36. This is 41. So the long side, when you square it, is less than the sum of the two legs that are squared. So if the long side is less, you have an acute triangle. Okay, let's look at 19. We're going to add, see if it's a triangle first. 4 plus 5, is that greater than 10? Well, it's 9. Is 9 greater than 10? No. So these three sides cannot make a triangle. So we're not going to bother to see if they're what kind it is, because it's not a triangle. Number 20. All right, checking to see if these would make a triangle. 4 plus 5. Right, take the two smaller ones. Is that greater than 8? Yes. 4 plus 5 is 9, so that is bigger than 8. So these do form a triangle. So now we want to know what kind. Okay, so we take the longest side, and that's 8, and square it. Is that less than, equal to, or greater than 4 squared plus 5 squared? Well, that's 64. That's 16. That's 25. So 64 and 41. 64 is greater than 41. So the long side, when you square it, is greater than the two legs, that are, or the two smaller sides, excuse me, that have been squared and added together. So this means it's obtuse. Okay, let's look at the next one. 4, 5, and 9. Can these form a triangle? 4 plus 5, is that greater than 9? No. 9 is not greater than 9. It happens to be equal to it. So these will not form a triangle. This is not a triangle. Remember, it has to only be greater than. Okay, 22. Our two smaller sides are 9 and 12. So 9 plus 12. Is that greater than 15? Well, that's 21. Yeah, 21 is certainly greater than 15. So yes, these make a triangle. Okay, what kind? We'll take the big side, that's 15, and we'll square that. Then we'll take the two smaller sides, 9 squared, and we'll add them together. Okay, so 15 squared. Remember, I'd like you to memorize these. That's 225. That's 81. That's 144. This is 225. If we add those together, we get 225. So this long side squared equals the sum of the two smaller sides that have been squared. This is the Pythagorean theorem in action right here. So this is definitely a right triangle. Right? If they're equal, the two sides are equal, we have a right triangle. Okay, and if you have a calculator handy, it can help us determine what the square root of 10 and the square root of 11 and the square root of 21 is. So the square root of 10 is something like 3 point, I don't know, I don't have my calculator handy, but 3.2, 0.1. And the square root of 11 is a little bit more than that. Let's say it's 3 point, I'm guessing here, 3.3, 3.4. Is that greater than the square root of 21 and the square root of 21? I'm going to get a calculator. Let's see. Square root of 21 is equal to, whoops, try that again. Square root of 21 is equal to 4.58. I know that these are bigger than 3 because the square root of 9 is 3. So anything bigger than that is going to be bigger than 1. There's something like this. If I add them together, we get 6 something, right? 6.4. I don't think that's exactly right, but they're definitely going to be bigger than the square root of 21. So these do form a triangle. Now let's find out what kind. Take the long side and square it. Then take the smaller sides and square each of those. Add them together. Okay. The square root of 21 squared is 21. Square root of 10 squared is 10. The square root of 11 squared is 11. 21 equals, see, this is 21 equals 21. So these two are equal, and since we're trying to figure out if it's acute, right, and obtuse, if these two are equal, we have a right triangle. Okay, a few more. We're going to simplify these expressions with these radicals in them. Now, if we're going to add them together, we need to make sure the radicands match. And in this case, we have a 6. In this case, we have a 24. But if we simplify this, we might get a 6 there. So let's see what happens. So this is 2 rad 6. That's simplified enough. All right, so this is 3 rad 24. I can rewrite that as 3 rad 4 times rad 6, right? 24 is 4 times 6. There's our perfect square. So that's 3 times 2 rad 6. So we get 6 rad 6. So I just rewrote 3 rad 24 as 6 rad 6. And now the radicands match. So we can add these together and we get 8 rad 6. Okay, 20, or B. Let's do B. Now we're multiplying. So when you multiply the numbers with radicands in them, you multiply the outside times the outside, that's 6. Then we multiply the inside times the inside. 24 times 6, that's 24, 2, 12, and 44. So we get 6 on the outside and the square root of 144 on the inside. Is 144 a perfect square? If you look at your factor pair sheet, you'll see that it is. So the square root of 144 is 12. And you get 72. Okay, let's look at this next one. We're adding, so we have to make sure the radicands match, and they do. We have 1 square root. Remember, this is pretend there's a 1 in there, an invisible 1. 1 rad 7 plus 3 rad 7s is 4 rad 7s. That one's done. And then when we multiply, we get rad 7 times 3 rad 7. Well, the 1 out here times 3 is just 3. And rad 7 times rad 7, if you want to do it the long way, you could do that. 49. But this is a perfect square. So 3 times 7 is 21. Okay. Now we're going to find h here. And this had to get changed. So this is 20 and this is 30. This whole thing is 32. When we drop down this height from the vertex to the opposite side at a 90-degree angle, we see we've created a 90-degree angle here and here. This is a rectangle here. So if this is 20, then this piece right here is 20. Well, if this piece in the middle is 20, remember I told you this triangle and this triangle on the edges are congruent. So I need 32 minus 20 is 12. I need 6 more on each side to make this 20 plus 6 plus 6. That's 12. 12 plus 20 is 32. So this whole side has been divided up. This piece right here matches this piece up here. And this is 6 and this is 6. Well, if I want to find h, I can use the Pythagorean theorem. H squared plus 6 squared equals 10 squared. So the height here times this little piece, these are both legs, and that equals 10 squared. H squared plus 36 equals 100, minus 36, h squared equals 64. Take the square root, that's a perfect square, so h equals 8. Now I'm asked to find the midsegment. Remember, the midsegment cuts from one leg to the other and meets at the midpoint. So this one and this one and this one and this one are congruent, and these are all parallel. I think somewhere I should have probably mentioned this is an isosceles. Trapezoid. We're going to add that on the next assignment. Okay, so to find the mid-segment, we add 20 plus the two bases. You add the two bases, divide by 2. So that's 52 divided by 2, which is 26. Mid-segment, or median. Find x. Okay, here we're going to make a altitude from that vertex down to here. And we're going to make that a right angle. So here's our altitude. We're cutting this piece into two figures. We have a rectangle here, and now we have a right triangle here. Well, this is a rectangle, then this piece is 5, then this piece is 5. This piece is x, then this piece is x. So this whole thing is 12, so that means that 12 minus 5, this piece is 7. If this piece is 5, then this piece is 7. And we can use the Pythagorean theorem to find x. This is a leg and this is a leg. They make up that 90-degree angle. 7 squared plus x squared equals the side opposite the 90-degree angle is the hypotenuse. 49 plus x squared equals 64. Subtract 49 from both sides. You get x squared equals 14 minus 9 is 5, 15. Take the square root of both sides and you get x equals the square root of 15. And that's done. Quick review on a parallelogram. It's a quadrilateral in which, well, the definition is opposite sides are parallel. Opposite sides are congruent. What else is congruent in a parallelogram? Opposite sides are parallel. Opposite sides are congruent. What about the angles? Opposite angles are congruent. And consecutive angles, ones that are right next to each other, are supplementary. They add up to. And then what bisects each other? The diagonals. And that's your assignment. I hope you have a great weekend, and I'll see you on Tuesday.